This video is on solid revolution, and I have a squash right here, and I want to find the volume of this squash. And then this type of squash, some people call it a birdhouse squash, and in the Vietnamese culture, we call it bo ho lo. And then because it's a squash, we can just cook and eat it just like a regular squash. But in the Vietnamese culture, people also use this type of squash to make a wine container. And then here's the picture of the birdhouse squash or bo ho lo that is still on the vine. And then people would use it and make a wine container out of it that looks like this. And so the process of turning a squash, of the birdhouse squash into a wine container, what people would do is they would allow a fresh cut squash to dry like this for several days, and then after a few days of drying it out, then people would cut like a little portion at the top like this right here, and then they would use like a stick to remove as much of the flesh inside of the squash as possible, and then to clean the inside completely, what some people would do is they would put pebbles inside of the squash and then add water, and then they just shake and shake and shake and shake until they remove everything from the inside of the squash. And then they would let it dry again, let it sit and just dry, and then they would turn it into a wine container. And then besides besides a wine container, people also make arts and craft out of these birdhouse or bo ho lo squash right here. But for this particular video, what I have here is the squash right here. It's about 22 centimeter tall, and I want to find the volume of this birdhouse squash or bo ho lo squash. And so here's the squash again, and then at the bottom of the squash, I have the x-axis right here, and then here's the y-axis. And so to get the volume for the squash, we will need the equation for the curves right here. And so what I did was I divided the squash into three portions. Here's the top portion, the middle, and then the bottom portion down here. And so I'm going to find the equation for this curve right here. And so this part right here looks like an upside down parabola, and so I'm going to try to fit it with an upside down parabola, or parabola that opens down. And so I came up with the negative 0.7 x squared plus 21.5, and that looks like a pretty good fit. And then we just want the top portion right here. And so the top portion right here, it goes about negative 1.7 to 1.7, and then we can find the volume of this top part up here. And then this curve right here, that looks like an ellipse, and so I fit it with on the ellipse. And so I fitted this ellipse right here is 3.4, 1 minus x squared divided by 13 plus 16.3. You just have to play around with it for a few minutes to get the curve that will closely fit. And then the bottom curve here is just a negative 3.4 times the square root of 1 minus x squared dividing by 13 plus 16.3. And then for the bottom part of the squash, the part up here is a little bit narrower than the bottom half down here. So I fitted this top part right here with the equation 7.5 times square root of 1 minus x squared over 64 plus 5.5. And then the bottom half down here is a little bit wider than this portion right here. So I fit it with negative 6.2 times the square root of 1 minus x squared over 64 plus 6.2. And now let's find the volume of each portion. So let's find the volume of the part at the top of the squash right here first. So here's the top portion of the squash, and then from here to here is about 1.7, and then from the x-axis up to this line right here is about 19.6. And so the equation for this graph right here is a function of x, and the axis of revolution is the y-axis. So it's probably best to use the shell method, because if we use the disk method, then we have to solve this equation right here for x in terms of y. We're going to fill this solid right here portion with the shells, cylindrical shells. And so here's the one shell, so let's call it the ith shell. And so the distance from the y-axis to the this inner cylinder right here, this would be from here to here would be x of I minus 1, and then from here to here would be x of I. And so right in the middle, which is the average radius of this shell, let's call it x of I star. And so the height of this shell will be the distance from this line right here, the line 19.6, up to the graph. But f of x of I, which is the distance from the x-axis up to this point on the graph, and therefore the height of this cylindrical shell will be f of x of I minus 19.6. And so we end up with negative 0.7 times x of I star squared plus 1.9. So the volume of this portion of the squash is going to be the integral from 0 to 1.7, 0 to 1.7, and then we have the 2 pi, and then the average radius is just x, and then the height will be negative 0.7 x squared plus 1.9 from here, and then thickness will be delta x or dx. And then to integrate this, we can use numerical integration like Trapezoid's rule, and it will come out to be about 8.0668. And now let's find the volume for this middle solid right here. The equation for this curve right here is 3.4 times the square root of 1 minus x squared dividing by 13 plus 16.3. So that's for this top half right here. And then the bottom half here is the same. So we can just find the volume of this top half right here and then double it, and that will give us the volume of this middle portion of the squash. So here's the middle portion of the squash, And then if we go from here to here, it's about the square root of 13. And then the line up here is about 19.6, and then down here is about 13. So right in the middle is 16.3. Once again, the equation for this curve right here is y equal to f of x equal to 3.4 times the square root of 1 minus x squared over 13 plus 16.3. Here is a function of x, and the axis of revolution here is the y-axis, so we'll go ahead and use the shell method. And so I'm going to fill this portion right here with shells, cylindrical shells. So here's the ith shell. So once again, the distance we're going to divide the interval from 0 to the square root of 13 into n sub-intervals. And then right here, this is the ith interval. So right here, this will be x of I minus 1, and right here is x of I. So right in the middle, which is the average radius of this cylindrical shell, and we'll call it x of I star. And so, and then the height would be the distance from this line right here, this horizontal line, to the graph. At this point right here, at x of I star, f of x of I star is the distance from the y-axis, from the x-axis up to the graph. So the distance from this point right here, this is, once again, this is x of I star. So f of x of I star will be the distance from this point on the graph to the x-axis. But the height is just from here to the line y equal to 16.3. And therefore the height of this shell will be f of x of I minus 16.3. And so the f of x of I star will be 3.4, square root of 1 minus x of I star squared, dividing by 13, and then plus 16.3. But then we have to subtract 16.3. So we end up with 3.4 times the square root of 1 minus x of I star squared over 13. And so the volume for this middle portion of the squash, we have 2 pi. The average radius will come from here, which is x. The height will be 3.4 times the square root of 1 minus x squared over 13. And then the thickness, which is delta x, or dx here. And then using numerical integration like Trapezoid's rule, we get 92.5722. So the volume for this part right here is 92.57, and therefore the volume for this lower half right here is also 92.572. And now let's find the volume of this last portion. And so for this bottom portion of the squash right here, are divided into the top half from here, and then the bottom half. And then for this top half right here is the equation is 7.5, 1 minus x squared over 64 plus 5.5. And then for this the bottom graph here is negative 6.2 times the square root of 1 minus x squared over 64, and then plus 6.2. So let's find the volume for this, the upper half right here. And so for this part, this line is y equal to 13, and then right here, this is y equal to 5.5. And then right down here is the x x's, we're going to use the shell method. From here, from the y-axis out to here, this is 8. So we're going to divide the interval from 0 to 8 into n sub-intervals. And this would be the ith sub-interval. So this is x sub I minus 1, and this is x sub I. So right in the middle, we'll call that x sub I star, which is the average radius of this ith shell. And then the height will be the distance from this line right here, which is the line y equal to 5.5, and then up to the graph, to this graph right here. Now at the right here at x sub I star, then f of x sub I star be the distance from the x-axis up to the graph. And therefore the height will be f of x sub I star minus 5.5. This line right here, 5.5. And so we get the f of x sub I minus 5.5, which is all of this, and then minus 5.5. Then we end up with 7.5 times the square root of 1 minus x sub I star squared divided by 64. And so the volume for this portion right here will be the 2 pi, and then the integral from 0 to 8 is 0 to 8. And then we get 7.5, for the average radius, it will be x, and then the height will be 7.5 times 1 minus x squared over 64, and then the thickness will be delta x or dx. And then using numerical integration, then we get about 1005. Now if we don't want to use numerical integration, if we just want to do regular integration, then we can use what's called the u substitution method. Let u be 1 minus x squared over 64. And then do the regular integration. And then we'll also end up with about 1005. And then the last portion of the squash down here, the graph is negative 6.2, 1 minus the square root of 1 minus x squared over 64 plus 6.2. And so here's the ith shell. The average radius is also x sub I star, and then the height would be from the graph up to the line y equal to 5.5. And so the right here, this is x sub I star. So f of x sub I star will be the distance from the x-axis from here to the graph. So this is f of x sub I star, and therefore the height will be 5.5 minus f of x sub I star, and we end up with this. And therefore the volume for this bottom part right here will be the 2 pi, the average radius is x, this is the height, and then the thickness will be delta x or dx. And then using either regular integration or numerical integration, we get 690.3126. And so in summary, the volume of this squash, this birdhouse squash or boholo squash, will be 1,888.83 cubic centimeters, which is 1.18888 liters. Recall that a liter is 1,000 cubic centimeters. So that's the end of the video.